In the next 3 videos, I'm going to be covering gross premium reserves from contingencies in actuarial mathematics. Now, this first video in the series will cover prospective reserves as well as a bit of theory, and then I'm going to make a quick note on my last video, which will lead nicely into this video. And then the next video will cover retrospective reserves, and the following video will cover a recursive relationship between reserves from year to year, as well as relating prospective and retrospective reserves when they are equal and why they are equal, and then also covering a special result. Okay, that's a special result is basically a shortcut. So stick around for all 3. There's a lot of useful stuff coming up for gross premium reserves. Okay, so let's start then with this note from the last video on gross premiums. So this note that I'm trying to make is the distinction between gross premiums and net premiums. So the gross premium can be thought of as the price of the policy, and the net premium can be thought of as the cost of the benefit. So the difference here is that if the net premium is the cost of the benefit, I'm not factoring in expenses. I'm not accounting for them, because the cost of the benefit, excluding the expenses, is what I'm going to be calling the net premium for this policy. Okay, but the price of the policy is what a policyholder will have to pay. Okay, and this policyholder will have to pay for the benefit as well as all the expenses that allow this policy to actually be in place in reality. And so we are going to be calling this price of the policy the gross premium. All right, now we have gross premium reserves and net premium reserves as well. Now, a gross premium reserve is exactly the same. The difference between the two is pretty much the exact same difference between gross premiums and net premiums. Gross premiums dealing with the price of the policy, including expenses, whereas net premium reserves, we exclude expenses. So then we think of net premium reserves as the amount of money that would need to be set aside only to meet the benefits, the expected benefits in the future. But the gross premium reserves would be the amount of money that needs to be set aside for this policy in order to meet all future outflows. Okay, and all future outflows then includes both expenses and benefits. Okay, now the first bit of theory for this video, or maybe second bit of theory, but the bit of theory specific to reserves, is what exactly are reserves then? So reserves are the amount of money that a provider will need to set aside in order to meet future liabilities. Okay, next bit of theory, quite a lot of theory at the start, but it does get to the maths part in a moment. So actuaries will endeavor to ensure that the expected benefits are greater than premiums in the later years of a contract to prevent a surrender. Okay, so in this case, surrendering does not benefit the policyholder, as they held the contract when the premiums were higher than the expected benefits and not later when it was the other way around. Okay, so this helps the insurer prevent being taken advantage of by the policyholder. Okay, so what exactly am I saying here? I'm saying that in the beginning of a contract, it costs the insurer money. This is the new business strain. To start this business, to go ahead with this policy, there's initial expenses, they have to set aside reserves. So it costs a lot to start a policy. And so to prevent an early surrender, the actuary will try and ensure that the expected benefits at the beginning of the policy are less than the premiums. Okay, so why is this the case? This means that later in the contract is where this person eventually wants to end up. This policyholder eventually wants to end up where the expected benefits would then become greater than the premiums, okay? So that this all levels out, because essentially our calculation is equating premiums and benefits. And so later in the contract, it must balance out these earlier years that are discouraging surrender. Okay, now let's get on to the maths here. Let's deal with prospective reserves. So a prospective reserve will equal to the expected present value of outgo minus the expected present value of income. Okay, so why does this make sense? Let's think about it. Well, we said the reserve is the amount that this insurer needs to set aside now to meet future liabilities. So what is future liabilities? Well, future liabilities in today's term is the expected present value of whatever I need to pay less what I'll be receiving. Okay, this is now the difference that is an outflow. Okay, so if I were to think of income minus outgo, that would deal with profits, but outgo minus income then deals with losses. So the amount that I need to set aside would be to cover this expected present value of a loss. Okay, that's my prospective reserve. I'm looking forward, okay, at future cash flows. And the notation that we'll be using to denote reserves at a particular time point t will be TV. Okay, and this is the reserve held at policy duration t, where duration 0 is the outset of the policy. Okay, and now let's also talk about the reserving basis. So the reserving basis is the set of assumptions that we'll be using to calculate reserves. Okay, it is also known as the gross premium valuation basis. Now be very, very careful, because this is not the same as the pricing basis. So you may think that it's the same because it's also known as the gross premium valuation basis, and premiums we know are to do with pricing. But note that it is not the same thing, okay? Be careful, because in questions they might ask you to use a certain basis, and then you have to know what they're talking about. And if they say gross premium valuation basis, know not to use the pricing basis, but actually the reserving basis. The clue in there is actually the word valuation in gross premium valuation basis. Okay. Right, so let's move on then. So a whole life assurance has the following future loss random variable, and you'll see why our gross future loss random variables are very important. Okay, it comes into reserves. Okay, so my gross future loss random variable at policy duration t is equal to SV to the tx plus t plus e, my renewal expenses, okay, and that's my annuity, and then plus this terminal expense, which obviously happens at the same time as my benefit, and then minus this gross premium. Okay, so all of this happens at duration t, which is why I always have x plus t in here, so the age is always x plus t. And then we understand why those two occur. You should definitely understand that, but now this is because my renewal expenses will be happening at the beginning of each year, and so I add that 1 over there, because if the person dies in the middle of a year, I would have still received the renewal expense at the start of that year. So it would be the number of whole years of life that they had left, plus 1 for this initial payment that's happening at the beginning of the year. Okay, and same thing goes for the premiums. All right, now the prospective reserve after T years, TV Pro. Now, if you are dealing with something where you have to explicitly talk about prospective and retrospective reserves in relation to each other, then talk about them like this. Your pro and retro in the superscript on the right hand side. That's how you should do it. But if they're just asking you to calculate and they say using prospective reserves, don't waste your time and keep writing the pro there. It's unnecessary. Okay, so TV Pro for this whole life assurance contract is equal to the expectation of this gross future loss random variable. Okay, and this equals to, which should be the expected outgo minus the expected present value of the income, as we wrote over here. And is that true? Well, this is the present value of outgo minus present value of income, and then I take the expectation of that, so I should get EPV outgo minus EPV income. Okay, now is this outgo, are all of these outgoes? Yes, well they are. It's my benefits and expenses, and this is my income, it's my premiums that I'll be receiving as the insurer. Okay, now in actuarial notation then, the expectation of this gross future loss random variable, which is the present value of my future loss, and that's a random variable. So the expected loss here will be S A bar x plus t plus E A x plus t plus F A bar x plus t minus G A x plus t. Okay, now please note that while I've said these are for whole life assurance contracts, don't be deceived into thinking that whole life assurances only ever have death benefits payable immediately on death. It could also be where the death benefit is payable at the end of year of death, in which case there wouldn't be a bar on top of that. Okay, so you just have to infer from the question what they want of you. They will say, and then you write whatever is desired. Okay, now just in the last video I found premiums that satisfy probabilities, percentile premiums, and now you might also have to find prospective reserves that satisfy probabilities. Now if I went and explained this as I did in the last video for percentile premiums, it would be an extremely long video, so I'm not going to do that. I urge you to go and look at that video, but the same core ideas and concepts and steps to follow are the same. Okay, so the understanding is the same to find prospective reserves that satisfy probabilities. So apply the same logic that I applied in the last video if you're ever given a question of this type, and try your best to find questions of this type so you can practice them. Okay, now the last thing for this video is this, not maybe a word problem type thing, but it is kind of like a word problem understanding type of thing. So let me go ahead and set it out, and then I'll explain what's going on. Okay, so let's assume that an insurer has two independent policies. Okay, now the reserve held for both of them will be less than double the reserve that needs to be held for one of them, given a probability of being able to meet its liabilities of at least a certain percent. Okay, now why is it the case that the reserve for both of the policies, both of these independent, that's very important, independent policies, is not just double the reserve for one? Why is that the case? Okay, so intuitively, so we know why we're working towards something. Intuitively, if you think about it, if I had a policy book of one person, and I multiplied this person's sum assured by 10,000, if this person eventually had this benefit owed to them, I would have to pay 10,000 times that benefit. Okay, now contrast that with the scenario where I have 10,000 different people. What are the odds then that all those benefits come up at the same time? Very, very slim. And so you'd probably think then that I don't need to reserve as great an amount as if I just had 10,000 times by the one person's sum assured, okay? Hopefully that's making intuitive sense to you. If I only have one policyholder, I'm going to need to reserve more for them, because if the event does actually occur where I need to pay them, I need to pay them in full here, and I don't have other policies that are balancing out the other side, okay? But if I have other policies that are balancing out, then I'll be receiving income from them as well, and so everything counteracts each other and everything converges to some expected reality, and so I need to reserve for less. Okay, so essentially the difference here then is variability. So let me explain here what's going on. So we know that the expected loss of both of them, I'm just going to call them L1 and L2 for each of these policies, will just be equal to 2 times the expected loss of one of the policies. Okay, that makes sense because my expectation acts linearly. So I can just separate these two random variables, and I have the expectation of L1 plus the expectation of L2, which is just 2 times the expectation of L. And if my expectation of L is my reserves, then 2 times the reserves is just the same as the reserves that need to be held for both of them. Okay, so the reserves that need to be held for both of them is the same as the reserves that need to be held for one of them times 2. Okay, but now if I need to meet my liabilities with at least a certain percentage, then things start to change here. So here's the variability coming into play. So while these expectations are the same, which leads us to believe that reserves should be the same, when I'm trying to meet liabilities with at least a certain level of certainty, then the reserves that I need to hold is not actually the same. Okay, so let me explain this. Variance of L1 plus L2 will be equal to 2 times the variance of L. Okay, you say to me that makes sense then. Okay, well then that means that the standard deviation of L1 plus L2 must be equal to the root of this, because standard deviation is the root of the variance. So I root both sides and I get root 2 times by the variance of L, which is 1.414, etc., times by, sorry, this should be standard deviation of L times by the standard deviation of this loss. Okay, so now you can see that the probability of making a loss will be smaller, so less reserves need to be held. Okay, so what am I talking about here? Well, I would have otherwise expected the standard deviation. Remember, standard deviation is intuitive. Variance is not so much intuitive, because variance is the difference between two things from the mean over all the values in this data set squared. Okay, so that's variance. Now that means I'm squaring all the differences. Standard deviation is much more intuitive than variance because I then root out that square. Okay, so standard deviation more accurately represents a spread from the norm. Okay, or at least more intuitively represents that. So if these expectations are equal, so 2 times for one of them is equal to one of both losses, one expectation of both losses, okay, then I would expect the standard deviation of both losses to be 2 times by the standard deviation of one loss, but it's not. The standard deviation of 2 losses is equal to 1.414 times by the standard deviation of one loss, which is less than 2 times the standard deviation of one loss. So let's explain this with the graph here. Basically, the variability, the variance has, not the variance, but the variability here has decreased due to the effect of the law of larger numbers.